Today I'm going to talk about our paper PromptIQ. Who cares about prompts? Let system handle it. A component-aware framework for text-to-image generation. I'm Nishan Chetri. My co-author is Arpan Senju. Let's talk about the paper. So, before starting, we can see recently text-to-image has a lot of broad impact in the industries, especially in the creative domain where arts and media are popular. But one thing to notice about this text-to-image generation is they really depends upon input text prompts. And if you see in this industry, people are not super familiar with the prompt engineering, and this is the new topic for them. And these people who don't have the idea of prompt engineering and those knowledge, they really struggle to generate good images. And another problem with this text to image generation is they also lack proper quality matrices to evaluate the generated images, which is a quite issue for now. So as we discuss, prompt really matters in case of generation, and poor prompts often lead to poor generation. And another important thing is image evaluation matrices. If we don't have good evaluation, then we won't get good image generation, of course. And on the slide you can see different images, for example car, bus and truck, but these images are generated with really poor prompt. For example, just the word car, bus and truck. And as you can guess, these words doesn't have super descriptive features to describe these subjects. That's why these text to image generation model are not able to generate these images properly, which is one of the drawback. So based on all these challenges, we are presenting an automated and interactive framework for those users who doesn't have proper prompt engineering, an iterative framework where they can get the good images without thinking about what kind of prompt they have to use. And we also develop one novel quality metric called CAS, component aware scoring technique, that measures this generation quality better than clip, and which we'll discuss in the results section as well. So let's dig down into our framework. We divided our framework into 5 different stages. The first one is image generation, where we'll generate images. The second one is subject extraction. The third one is subject segmentation. And the fourth step is user interaction, where user will interact with the system again, whether to decide they want to pursue more or not. And for the fifth is prompt modification. So let's start with the first phase. In this phase, user will give prompt to the stable diffusion system or one of the text to image generation system, and this will generate image, and this image is not shown to user now. It goes through other different evaluation technique before showing to the user. And in the second phase, the SAM algorithm, segment anything model, developed by Facebook, it extracts the subject from the generated images, and it removes all the irrelevant background. And for the third step, these extracted images further segmented into different components. As you can see, the car is first extracted from irrelevant background, and then it's divided into different components like wheel, door, and we'll evaluate the score. We'll evaluate these components, and then we'll get the CAS score, which is component aware score. We're using algorithm second, as mentioned in the paper, to get this score, and we'll quickly discuss here as well. So if you see here, each component will generate caption using blip captioning model, and this caption will be compared to true label of the subject. For example, for car, The true labels might be wheel, door, windshield, grill, and for bicycle it might be pedal, handle, headlight, and those kind of thing. And we once we get the caption and true label, we'll compare these to text embeddings using sentence bird, which is one of the popular and good technique in the like while comparing the similarity between different texts. And we'll get the component score, and we'll update our cache score if we get the highest component score. So, and we'll repeat for all the components. And once we get the cache score, we'll return to the algorithm 1 again. So with the help of this algorithm 2, we'll have the cache score, and we'll compare this cache score with the user threshold. If the cache score is greater than user threshold, image is displayed to the user. Otherwise, it will go to the next section. And but at the end, user has ultimate power to decide whether they want to pursue to the next step or not. So if they don't like image, irrespective of it get a higher score, user can always ask for regeneration. And once they do that, the system goes through the prompt modification, and the modified prompt goes again into the text to image generation model, and the cycle repeats. So yeah, this is the summary of all 5 stages. And we compare our technique with the clip, as we mentioned before, and you can see our framework has pretty good results, and those are highlighted with the red colors. For the bad images, that is in the initial prompt section that doesn't have proper description for the subjects, we have pretty low score. And for the modified prompt, who does have better prompts and description for the subject, we have better score compared to clip. And if you see the clip score, they have almost similar for both the good and bad images, which also mentioned in the motivation. That's the shortcoming of the clip. So yeah, for the future, we are planning to add more functionality for user to get more control, and for this we'll add support system for multiple diffusion model. We'll also provide user driven prompt refinement and those kind of things in the future work. So to conclude, yeah, we developed an automated framework that also handles a poor prompt with iterative feedback loop, and user has always control over what to generate and how many times they want to generate it. And our system also outperformed clip across different subjects. So now let's see some of the demo here. So at first, this is the layout. User can give input. For example, it gives car. And let's try to see if we decrease the threshold, what kind of image it will generate. Yeah, so it doesn't have any prompt modification right now, so the image is pretty bad. Now user decide they don't like this image, and they want to increase the threshold to see how good image will be with this threshold barrier. Okay, this is good image compared to the last one. And if user like it, they can say yes and stop the process here. But if they want to do more, they can always change the subject prompt and see for the next generation. And they can play around different threshold, different subjects, and they can generate multiple times. So user don't like this, so they increase the threshold. And let's see how the image looks like. Okay, this is comparatively good. So if user finds some defect or they don't like image, they can always ask for another generation. So in this way, the system works and user has ultimate control.